Namaste, dear students. Today we are going to talk about bonds, electrovalent bond, and characteristics of electrovalent compounds. In our earlier class, as we have discussed about the electronic configuration, how does the electrons of an atom can be configured in different cells, as well as by losing the electrons and by gaining the electrons, the atom does acquire the positive as well as the negative charges. So, they are known as the ions. We have talked in our earlier class. And finally, we talked about the balances of the respective atoms. And valency of the atoms depend upon the number of electrons present at the valence shell and number of electrons that the atom gains or number of electrons that loses. So, these were discussed in our earlier class. Today, we are going to talk about first what is ions. As in our previous discussion that the ions are formed by gaining the electrons or by losing the electrons. I think you are quite familiar with this term. That means ions are the charged particles. When the atom gains the electron or when atom loses the electrons, the atom becomes charged particle, that is called the ions. Ions are of two types. They are positively charged ion, that is cation, as well as the negatively charged ion, that is known as anion. But how does the bond is formed between the atoms of a compound? We are going to talk about this matter today. So, that means, in fact, what is bond? How does bond form? As well as what type of bonds can the atom form? In this area or in these subtopics we are talking about, is you are looking in the screen that the linkage between the atoms or linkage among the atoms of a compound, that is called the bonds. This linkage is due to the electron sharing of the electrons or by transferring the electrons. If the one atom loses electrons, then these electrons are gained by other atoms and they do have got some linkage, they do have got some connection. So, that is called bond. Bond can be formed by either sharing the electrons or by transferring the electrons from one atom to another atom. Just you can see here, there are two atoms of hydrogen, as well as how does the molecule of hydrogen form? In the valence shell of hydrogen, you can see only one electron. Here you can see here the single dot represents one electron of the one atom of hydrogen, as well as another dot represents the one electron present in the next atom of the hydrogen. So, altogether there are two atoms of hydrogen, and these two atoms of hydrogen are being connected by the electrons. These electrons, one electron from this atom as well as one electron from this atom are being shared, and it has made a combination, it has made a linkage, that is called the bond. So, they do these atoms are sharing the electrons. So, this linkage is formed by sharing the electrons. Similarly, in the next example, you can see the molecule of oxygen. As we have already discussed in our earlier classes that in the valence shell of atom, oxygen atom, there are 6 electrons. Then how does the molecule of oxygen acquires the octet state, or how does the molecule of the oxygen form? The molecule of oxygen is formed by sharing 2 electrons from each atom. That means 2 electrons is being shared from this atom as well as 2 electrons are being shared from this atom. So that if you count the total number of electrons formed inside of this second orbit of the oxygen, altogether 8. That means 1, 2, 3, 4, 5, 6, 7 and 8. So, this atom has acquired the octet state. Similarly, in the next atom also if you count, you will find the total number of electrons in the valence shell is 8. So how does this 8 electrons in the valence shell of oxygen become? Obviously, 2 electrons from the another atom of oxygen has been shared by this atom. So it has acquired the octet state. So this is due to, or this linkage is formed by sharing the electrons between 2 atoms. So this is also known as the bond. So O2, that means molecule of oxygen, is denoted by O2, and O2 is formed by sharing of 2 electrons from each atom, like this. Similarly, in the molecule of water also, the molecular formula of water is H2O. It includes 2 atoms of hydrogen as well as 1 atom of oxygen. Then how does the linkage between hydrogen and oxygen occurs in water molecule? You can see here, that means altogether there are 6 electrons in the oxygen. We are quite familiar with the electronic configuration of the oxygen. So in the second cell of oxygen there are altogether 6 electrons. So 1, 2, 3, 4, and 1 electron from this oxygen as well as 1 electron from this oxygen. But 1 electron of this orbit is from the hydrogen, because hydrogen has 1 electron in its valence shell. So it has shared this 1 electron with the oxygen atom. In the next side also, hydrogen has one electron in the valence shell. Then this electron has been shared with the oxygen atom, so that this becomes a molecule of water. So in this water there are 2 linkages. One linkage is being seen at the side, as well as another linkage, that is another bond, has been seen at the next side, because altogether there are 2 hydrogen atoms. They are sharing 1 electron with the 1 electron of the oxygen atom. So it is the bond formed between hydrogen and oxygen in water molecule. Similarly, in the next example, what is the would you mind to think that what is the difference between the linkage formed between this water molecule as well as this one? Do you have got any idea what is the difference? Yes, exactly. Yes, you are thinking that magnesium has 2 electrons in its valence shell, and this is the oxygen atom. So this magnesium metal has lost 2 electrons. Then these two electrons are being acquired by or accepted by the oxygen atom, because when the magnesium loses 2 electrons, it acquires octet state, as well as when these oxygen atoms gain 2 electrons, then it acquires duplet state. So there are there is the similar that needs for both atoms. That means magnesium needs to lose 2 electrons to be octet, as well as oxygen needs to gain 2 electrons to become octet. So they do have got the similar that needs. That means it needs to lose 2 electrons, it needs to gain 2 electrons. So they do have got this type of bonding. That means in this magnesium and oxygen also there is the similarity. That means magnesium has lost. So this bond is formed by losing the electron or by transferring the electron from one atom to another atom. That means bonds can be formed by not only sharing the electrons, but also by transferring the electron from one atom to another atom. So this is the a bit different type of that bond, that is called the electrovalent bond, because electrons are being just transferred from one atom to another atom. You can see in this compound also, that means this is the compound of carbon dioxide. So how does carbon dioxide molecule form? Then what type of linkage do we find in the carbon dioxide molecule? Just you can imagine that there are 2 places or 2 linkages. That means one linkage is looked over here, as well as another linkage has been seen in the next side. That is in this that part you can see the linkage between the carbon as well as the oxygen. So here oxygen has shared 2 electrons, as well as carbon also has shared 2 electrons, because this blue balls represent the electrons of the carbon, as well as red balls or red electrons are the electrons of the oxygen. So 2 electrons are being shared, as well as in the second part or the next part there are 2 balls of the carbon as well as 2 balls of the oxygen. So in 2 sides there are sharing of 2 electrons are being seen. That means these are the linkages by sharing the electrons. Now, in this molecule, you can see the transference of the electron from this sodium metal to chlorine. Is we have already configured the electrons of the sodium as well as the chlorine. Sodium does have got 1 electron in the valence shell, as well as chlorine does have got 7 electrons in the valence shell. So chlorine needs 1 electron, as well as sodium needs to lose 1 electron, so that when the sodium loses 1 electron, then this lost electron will be gained by the chlorine. So this is the bond formed between sodium and chlorine, and it becomes sodium chloride. How does this sodium chloride form? By losing the electron from the sodium, then this lost electron is gained by the chlorine, so that both of the atoms have got the octet state right now. So this type of linkage, which is formed by gaining the electron or by transferring the electron, is called electrovalent bond. Generally, to classify the nature of the bonds, that means some of the bonds can be formed by mutual sharing of electrons, as well as some of the bonds can be formed by transferring the electrons. On the basis of either sharing electrons are being shared or electrons are being transferred from one atom to another atom, there are two types of the bonds that can be formed by different types of the atoms while making the compounds. So they are electrovalent bond. Some of the compounds are formed by that transferring the electron, as well as the electrons while making the while forming the compound. If electrons are being shared within the different atoms, then this type of bonds are also known as the covalent bond. But today we are going to discuss about what is electrovalent bond, as well as how does it form, as well as what could be the different types of the characteristics that can be shown by the electrovalent compounds. Are you ready? Yes, for the discussion of electrovalent bond, I think you all are ready, and you I hope you do have got the copies as well as the pens with you, and if you feel the things are need to be copied in your copy, then it is better to write note down in your copy, and you can read after this class. Some of the atoms which do not have got, or which do have got the doublet state, like helium, as well as neon and argon, krypton, as well as the xenon. These atoms have got the stable state electronic configuration. That means this atom has got 2 electrons in the valence shell, as well as the second atom has got 8 electrons in the valence shell, and it does have also got the 8 electrons in the valence shell, and this atom has got 8 and 8. It means they do not need to gain as well as to lose the electrons or to share the electrons to become stable, to become inert, because they are already in the duplet or the octet state. In such states, the atoms neither need to gain the electron nor need to lose the electrons to become stable or inert, that means passive. So these atoms do not react, or generally these atoms are also known as inert elements, inert gases, because generally in room temperature they are found in the gases, so they are also known as inert gases. These atoms neither make the covalent bond nor they make the electrovalent bond, because they do not have the need of gaining the electron as well as losing the electrons. So the atoms which are in duplet or octet state, they do not gain the electron as well as lose the electron. So have shown in the diagram that they have got duplet as well as octet state, so they do not need to gain the electrons as well as lose the electron. Generally you can see the examples like neon, argon, krypton, xenon, etc. are in the octet state, but helium is in the duplet state. And chemically these type of atoms are chemically inert. They are the inert or stable that atoms, so they do not react. But when the bonds are formed by transferring the electrons, they are known as the electrovalent bonds, or this type of linkage is also known as the electrovalent linkage. For example, you can see, so we just have discussed about the formation of sodium chloride, and we are just going to repeat the same thing here, because we are going to know how does the electrovalent bond form. Is you can see here, that means sodium as well as sodium as well as chlorine, they are going to be combined to each other to form a new bond or to form a compound. While they form the compound, they do have got some needs, or they sodium metal needs to lose one electron, as well as chlorine atom needs to gain one electron. Then it becomes Na plus as well as Cl minus. But when they form a compound, then this forms, okay, this structure. That means sodium metal is losing one electron, so that it has acquired positive charge, as well as chlorine atom has gained the electron lost by the sodium, so that it acquires the negative charge. Also, it is electronegative, it is the electropositive. And if the bond is formed by such that phenomena, that is such processes, that by losing the electrons or by gaining the electron, then this is known as the electrovalent bond. I think you can see it here, and you can, I think it is quite easy to know the red ball, that is the valence electron present at the sodium metal, has been transferred to the valence shell of the chlorine, and it has acquired the octet state, and it also has acquired the octet state by losing the electron. You can see here, this is the state when sodium has lost the electron, as well as chlorine has gained one electron. So this is the final state. So if the bonds are formed by such methods, that means losing as well as gaining the electrons, this type of bond is known as the electrovalent bond. Similarly, in another example, you can see here what is happening in the chlorine as well as what is happening in the magnesium. Just you can make guess, and you can write in a copy also. There are altogether 2 electrons in the valence shell of magnesium and 7 electrons in the atom of chlorine. There are altogether 2 chlorine atoms. So 1 electron of the magnesium will be transferred towards the 1 atom of chlorine, as well as 1 electron of the magnesium metal will be transferred or is being transferred towards the another atom of the chlorine. So by losing 2 electrons from the magnesium, I think you can see there is the octet state of chlorine also. In this chlorine also, it has got the, or it has acquired the octet state. If you count the total number of electrons after gaining the electron from the magnesium, then obviously you will find 8 electrons in the valence shell, that is 1, 2, 3, 4, 5, 6, 7 and 8. Altogether 8 electrons are being found at the valence shell of the chlorine. Similarly, in the next atom also, altogether there are 8 electrons, so it has acquired the octet state, as well as in the magnesium also there will be 8 electrons in the valence shell, because the third shell, that means M shell, has been lost, because there are altogether there were 2 electrons in the valence shell, so these 2 electrons have been lost. So this is the linkage formed between 1 atom of magnesium as well as 2 atoms of chlorine. So this linkage has been formed by transferring the electrons from one atom to the another atom. So this is another supportive example to know, or to know about the electrovalent bond, because this type of bond has been formed by transferring the electrons. You can see mathematically how does the electrons are being shared from magnesium to chlorine. You can see here altogether there are 2 electrons from the magnesium have been lost, so that it has gained the positive charge. So it is electropositive charge, that is Mg++. When 2 atoms of chlorine gain 2 electrons, and 1 atom gains 1 electron, as well as another atom gains 1 more electron, and so that there will be 2 chloride ions. They are being formed by gaining 2 electrons from the magnesium atom. Similarly, we have got another example also, that is calcium chloride. The molecule of calcium chloride is being shown here. I think it is quite easy to know, because magnesium as well as calcium lies at the same group of modern periodic table, so that calcium does have got 2 electrons in the valence shell, and this calcium is losing 2 electrons, and 2 electrons lost by the calcium are being accepted by 1 atom of chlorine here, so that altogether there were 7 electrons in the valence shell of chlorine, and when it gains 1 electron, then it becomes negatively charged, and that means the linkage between calcium as well as chlorine will be occurred by transferring the electron, as well as another electron of the calcium atom is being transferred towards the another atom of the chlorine, so that it becomes that octet in the second atom of the chlorine, and altogether here will be 8 electrons, and here is also 8 electrons. Then in the valence shell of calcium also 8 electrons. So how this type of compound is formed? I think it is quite easy to know that the electrons of calcium has been transferred from transferred to the chlorine atom, so that the linkage between calcium and chlorine has been formed by transferring the electrons. So this is all about the bond formed between the calcium and chlorine, and calcium and chlorine has been formed, or calcium chloride has been formed by transferring the electrons. So it is about all about the electrovalent bond. And this is all about the electrovalent bond. What is the procedure to be formed the electrovalent bond, and what would be the that atom when the atom gains the electron, and what would be the charge in the atom when it loses the electron. When atom loses the electron, then it does acquire the positive charge, so they are also known as the electropositive ion. As well as when the electrons are being gained by the atom, then they do have got the negative charge, and they are also known as the electronegative ion. And if such type of compounds are formed by transferring the electrons from one atom to another atom, then they do have got certain characteristics. They have got a bit different characteristics rather than the other compounds which are formed by sharing the electrons. Then what are the general characteristics of the electrovalent bonds? We are going to discuss over the topic, that is characteristics of the electrovalent compounds. Electrovalent compounds which are formed by transferring the electrons, generally this type of compounds are formed by the metals as well as the non-metals. Metals generally lose the electrons, as well as non-metals generally gain the electrons, and the linkage between metal and non-metals is occurred by the transference of the electrons. So generally this type of compounds does consist the metal as well as the non-metals. The electrovalent compounds which are formed by sharing the electrons, transferring the electrons, then generally they are known as the polar compounds. That means they are soluble in water. They can easily dissolve in water. They can form the homogeneous solution with the water. So they do have got the dissolving tendency, because water is polar solvent, as well as when the electrovalent compounds are formed, these compounds are polar compounds. They can easily be dissolved in water. Similarly, they form cation as well as anion when ionized. When the compounds are ionized, then they form cations as well as the anions. You can just see when NaCl is ionized, it can form Na plus as well as Cl minus. This is cation, this is anion. Similarly, if you take another example, that means MgCl2, when you ionize this magnesium chloride, obviously you will get two ions. They are Mg++ as well as 2Cl minus. Mg++ is cation because it consists positive charge, as well as Cl minus is anion. As we have discussed, the charges which have got positive charge, they are known as cation, as well as the charges or the ions which do have got the negative charge, they are called the anions. So if you see these examples, obviously if this electrovalent compound is ionized, this is the electrovalent compound, because this salt is formed by transferring the electron from sodium to chlorine. And if you ionize this type of electrovalent compounds, then you will get two ions, they are cation as well as the anions. So this is one of the characteristics of the electrovalent compound. Similarly, if the compounds are formed by the electrovalent bond, then they do have got a bit higher melting as well as the boiling points. Because if the bond is formed by transferring the electrons, then this type of bonding is considered a bit more stronger rather than the compounds which are formed by sharing the electrons. So if the bond is stronger, then we need to supply more amount of heat, so that if more amount of heat is supplied, then they will have, or such compounds will have got more melting point as well as the boiling points also. They conduct electricity in molten state. When the electrovalent bond, electrovalent compounds are dissolved in water, then these type of compounds are gives the two types of ions, cations as well as anions. When we want to conduct heat and electricity, generally electricity, then this type of ions will carry the electrical energy from one end to another end, so that they can easily conduct electricity, because the ions will carry the that energy or electrical energy from one part to, or one from the source to another part. That means they do have got the that conducting capacity, that is they are the good conductor of heat and electricity. When they are dissolved in water, then they do have got the ions. These ions will carry the electrical energy from one part to the another part. As well as generally they are found in crystalline state. Is you have already got the point that crystal is the that substance which do have got the that shining property, as well as they do have got the geometrical shapes. So generally the electrovalent compounds are found in such states. Generally they do have got the fixed geometric shapes, as well as they are found in the, or they do have got the shining nature also. So this is all about the characteristics of electrovalent compounds. In our today's class, we have talked about the how does the bond form, and what are the types of bond, whether the bonds are formed by the sharing of electrons or by transferring the electrons from one atom to another atom. When the atom gains the electron, what could be the charge over it, as well as when the atom gains the electron, what could be the charge present over it. So on the basis of these gaining as well as losing the electrons, then the ions are of two types. They are cations as well as anions. And finally we discussed about the electrovalent compounds and their characteristics. Now we are going to talk about some questions related to today's class. So some of the questions are being presented over the screen, and we are going to discuss over this. Please take a pen and copy, and try to copy the questions in a paper, and we'll be discussing over there. So what is the electrovalent bond? You have got some options, that is bond formed by sharing the electrons. Is this the electrovalent bond? Bond formed by transferring the electrons from one atom to another atom. Is this the correct statement? Or bonds formed by electrifying the electrons. That means electrons are being electrified, energized, as well as bonds formed by neither donating nor gaining the electrons. Which of the statements over these all options is correct? Can you make guess? Yeah, as you are guessing, this is the correct answer. That means bonds which are formed by transferring the electrons from one atom to another atom, that is called the electrovalent bond. I think you have you also have got the correct answer. I think you did the correct you take the correct option. In the second, we have got one question, that is what type of bond has formed in the figure, explain. We have to explain by studying the figure there. That means as we have discussed in our class also, that is magnesium metal has kept at the middle, and there are two atoms keeping aside from the magnesium metal, so they are chlorine and chlorine. Then what type of bond can the compound form? Can you make guess? Yes, what is happening in the first state, that is from the valence shell of the magnesium is being transferred towards the chlorine atom. One electron from this magnesium towards the valence shell of the chlorine. And towards this side also, the valence electron of the magnesium is being transferred towards the valence shell of this atom, chlorine atom. That means this bond is going to be formed by transferring the electron from one atom to another atom. So this is all about the electrovalent bond. How does electrovalent bond form? Can you say? Yes, electrovalent bond is formed by the transferring the electron from one atom to another atom. So if this is so, then you can see the electron is being transferred from magnesium to chlorine atom. So it is all about electrovalent bond. So the type of bond that can be formed in this molecule is electrovalent bond. So you can explain in your own words also by knowing this fact by looking the structure here. Similarly, I have a question, that is, draw the diagram of process of formation of sodium chloride molecule. How does sodium chloride molecule form? You should have, please draw the structure. That is, first step, what is the total number of orbits present in the sodium metal, as well as what is the total number of orbits present over the chlorine. Then try to draw the figure. Then how does the electron from the sodium shift from the valence shell of the sodium towards the valence shell of chlorine? You need to just draw the figure and you can explain. And in the question number 4, you are looking generally what type of bond does the given atom form and why. That means, first of all, you have to identify which atom has been shown in the figure. That means by counting total number of electrons present over the different orbits. If you count, there is 2 electrons in the first orbit, as well as 8 electrons in the second orbit, as well as 7 electrons in the valence shell. That means if there is only 1 electron that needs to that it is needed for to become octet state, then obviously if it gains 1 electron, then by gaining the electron, obviously it forms the electrovalent bond. If this atom can share the electron, or if this atom share the electron, then this forms another type of bond we will be discussing in our later class. But today we are discussing about the electrovalent bond. So it is all about, or this atom generally forms the electrovalent bond because it needs 1 more electron to be octet. Next question is, what are the characteristics of electrovalent compounds as well as the electrovalent bond? Generally, if you are talking about the electrovalent compounds, these electrovalent compounds are formed by the electrovalent bonds. So if we have discussed about the electrovalent compounds, if you are writing the characteristics of electrovalent bond, it is all about related with the electrovalent compounds also. So generally, the electrovalent compounds have got higher melting point as well as the boiling points, and electrovalent compounds are formed by the metals as well as the non-metals. Metals generally do have got the electron donating nature, as well as they are electropositive nature, as well as non-metals they generally acquire or they accept the electron which are lost by the metals. So they generally form the electrovalent compounds. That means metals as well as non-metals generally make the electrovalent compounds. Similarly, metals as well as non-metals, when they make the bonds, then they do have got the ionic nature. That means when they are dissolved in water, then they form different types of ions, as well as when the metal as well as electrovalent compounds have got the tendency to conduct electricity also, because in the ionic form they can easily conduct electricity. We have just made the discussion in our earlier slide. And electrovalent compounds have got the geometrical shape, as well as they have got the crystalline nature, and they do have got the shining nature also. So these are the general characteristics of the electrovalent compounds as well as the electrovalent bonds. Another question is, why calcium chloride compound is called electrovalent compound? Why the calcium chloride salt is formed, and why this compound is called the electrovalent compound? What could be the reason behind this? What type of bonds are, or what type of compounds are called electrovalent compounds? Calcium is metal, chlorine is non-metal. From the first point of the characteristics, it suggests that it is the compound formed by the metal as well as non-metal. As well as when you ionize, then you will get Ca++ as well as Cl minus. It means it does have got two types of ions. So in this sense, this is electrovalent compound. As well as when you dissolve in water, then it forms two types of the ions, as I have talked about this. And when you see the calcium chloride crystal, then you will find it has got a bit shining nature, as well as it has got a fixed geometrical shape also. So it does have, or it is called the electrovalent compound. Whatever the characteristics of electrovalent compound are there, then just try to relate with these properties, these characteristics with the calcium chloride, so that it will be your fine answer. You have to explain the ionic reactions also, and you have to draw the structure of calcium, atomic form of calcium as well as atomic form of chlorine. Then when calcium loses 2 electrons, how the structure of calcium Ca will be changed, as well as when electrons are being gained by the chlorine, how the structure of atom of chlorine forms. You have to just write down the structure, and you have to explain the all necessary steps to write the correct answer of this question. And then finally, we do have got some project work, one project work, that is you have to draw a molecular formula of aluminum chloride and magnesium oxide. We have got 2 project works in individual chart papers. Please take one chart paper and try to write the atomic structure of aluminum as well as atomic structure of chlorine. Then you have to take 1 atom of aluminum and 3 atoms of chlorine, because the molecular formula of aluminum chloride is AlCl3. Then how the electrons of the aluminum shift towards the chlorine, and after shifting the electron from aluminum to chlorine, what could be the changes in the structure of the electrons present in the valence shell. You have to show these electrons, which electron has been shifted, as well as which electron has been just gained by the chlorine. You have to try to indicate these electrons which were within the same atom, or which electrons are being just shifted. You have to just try to indicate these electrons in your diagram, and you can show your teacher not only about the structure of aluminum chloride, but also in the structure of magnesium oxide also. Just make the atomic structure of magnesium, then how many electrons does the valence shell of magnesium acquire, as well as draw the structure of atomic structure of oxygen also. In the valence shell of oxygen, how many electrons does the oxygen atom acquire? You have to draw the structure. Then try to make the linkage or the bond formed between magnesium and oxygen. How many electrons are being shifted from magnesium to oxygen? Try to make the draw the differences in the structure in the atomic form, as well as in the when the bonds are formed, as well as when the compound is formed, and try to demonstrate all of the processes, what is happening in the atomic form, as well as what is happening in the molecular form, as well as when the magnesium loses the electrons, then what is the ionic form of magnesium, as well as when the oxygen atom gains the electron, what could be the ionic form of the oxygen. You have to show all of the steps and try to show your teacher. Today we discussed all about the nature of the bonds, as well as things of the things which are being changed when the atom becomes ion, and what are the characteristics of the electrovalent compounds. We have discussed all about these things in our today's class. I hope you all enjoyed in today's class. Please try to be engaged in your study throughout by looking by looking these slides, as well as by looking these materials. So I want to conclude today's class. Thank you everyone.